Alright, so welcome to the second day of notes of Unit 3. These are called radians. So what is a radian? A radian, in other words, is just a number. So when we were talking about angles, we were talking about like the measurement of an angle from one side to another. So like here, this was an angle measure, and usually it's in degrees. Well, a radian measure is talking about the length from here to there. Okay. So we're trying to figure out how do we measure that? Like, what is that radian? Well, every circle has a radius. If you were to figure out the length of that, that's called the circumference. So something that you need to remember is that the circumference of a circle is 2 pi r. So it's the arc length. That's what a radian measure is. It's the measure of the circumference of that angle measure. So they kind of could represent the same thing, but one's in degrees and one is just a number. And this is why we have those two modes in the calculator. So let's go back to this unit circle. So what I'm going to do is I'm going to kind of draw this as our unit circle that we had before. Okay, so something like this, where in degrees, or well, actually, let's first talk about that in this unit circle, we have a radius of 1. Well, if I ask you what is the circumference of a unit circle, you would plug in 1 for the radius, so your circumference would be 2 pi's. That means that if I started here at my initial side, like what we did with 0 degrees, and start off with 0, because 0 is a number, 0 degrees is an angle measure, and go all the way around, that should be 2 pi's. Well, if I go halfway around, that should be pi. If I go a quarter of the way, it's half of a pi, so pi over 2. If I go down, that's going to be 1.5 pi's, or 3 pi over 2. So in radians, this is going to be almost the exact same thing that we had as 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360, but these are in terms of radians. So what we're going to be able to do is everything that we had in degrees, we're going to also be able to do in radians. So how do I draw a radian of pi over 3? Well, just like with degrees, we're going to start with an initial side. You could draw out a little coordinate plane if you wanted to. Know that going straight up, that used to be 90 degrees is pi over 2. So the question is a third bigger or smaller than a half? What's smaller? And so my pi over 3 is going to look something like this. So that's what pi over 3 looks like in radians. What quadrant did that terminate in? Because that's what the directions say, 1. So what about 4 pi over 3? Well, if you think about that, that's the same thing as 1 1/3 pi. So 1 pi would be what used to be 180 degrees, like half of a circle. And then 1/3 of a pi is going to be less than a half still, so it's not going to go straight down, but it's going to terminate in quadrant 3. So that's what 4/3 of a pi look like. What about 4 pi's? Well, one full circle is 2 pi's, so if you go around again, it's 4 pi's. So that's what that looks like. If it's asking you for a quadrant, we can just say it's in the positive x-axis. What about negative 5 pi over 6? Well, negative 5 pi over 6 is going to go in the clockwise rotation, but not quite yet a full pi. So it's going to look something like this. So it's going to terminate in quadrant 3. 7 pi over 6, again, you can think about this as a mixed fraction as 1 1/6. So that means we're going half of a circle and then a sixth more. So something that looks like this, that terminates in quadrant 3. What about negative 5 pi's? Well, we're going to go into clockwise rotation. Here's negative 2 pi's, negative 4 pi's. And if I want one more, I would just end up going another half circle, which is a pi. So it looks like that. So that's going to terminate in the negative x-axis. Now, do all of our radians have to be in terms of pi? No. Radians, again, are just numbers. So if you want to, you can use a calculator right now real quick to figure out what 0 pi's is, which is 0. Pi over 2, which is about 1.57. Pi, which everybody should remember, is 3.14. And then 3 times pi divided by 2 is 4.71, and then 6.28. So this is all the pi's, but in numerical values as decimals instead of in terms of pi, because you can still draw 6 radians, because 6 radians is a little less than 6.28. So something that looks like that. That's what 6 looks like. So that's going to end in quadrant 4. Same thing for negatives. If I draw this coordinate plane, and I'm going to go in the clockwise rotation, so I'm going to have 0 here, but then negative 1.57 is here, negative 3.14 is here, negative 4.71 is here, and then negative 6.28. So where would negative 4 go? Well, it's going to be a little less than negative 4.71, so something that looks like this that terminates in quadrant 2. So if I give you 9 pi over 7, is that the same thing as 9 sevenths? Well, if we put this into the calculator, 9 times pi divided by 7 gives 4.04. 9 sevenths is only 1.29, which if I graphed, or if I drew this out, 404 would end up terminating quadrant 3, where 1.29 is going to be a little less than 1.57, so it's something that looks like this. So pi, in terms of pi and not having pi, they're both radians. However, they're both different depending on if it has a pi or not. So if we can draw all of these radians like what we do with angles, we can do the same thing with all the other stuff that we did with the angles, like finding coterminal angles. But in radians, it's different than degrees. If I'm going to be finding coterminal angles, I need to add a circle to it. Circles in radians are 2 pi's. So what I'm going to be doing here is figuring out what the coterminal angle is by just adding 2 pi to this. So 7 pi over 6 plus 2 pi, well, in order to add fractions, you need a common denominator. So 12 pi over 6 is the same thing as 2 pi's. So 19 pi over 6. I could do the same thing for the negative one, but subtracting 2 pi, which again, as a common denominator is 12 pi over 6, so you end up getting negative 5 pi over 6. So there's one positive and negative coterminal angle. What if I give you 4 pi? Well, I could add 2 pi to that, but that's just going to get more positive. I want to get the smallest positive, so I'm going to subtract 2 pi. Well, that's one answer. If I subtract another 2 pi from that, I get 0, which is not negative nor positive. So I'm going to subtract another 2 pi and get negative 2 pi. So a positive and negative coterminal angle for 4 pi, there's a lot of different answers, but these are just the smallest positive or negative versions of that. Well, if the relationship between a full circle in degrees is 360 versus 2 pi radians, that means that I can reduce that and say that, well, if 180 degrees is a half a circle and pi is also a half circle, then that means that they're the same. So what we're going to be doing here is we're going to convert from one to the other. And this is almost like what you do in science with dimensional analysis. So I'm going to multiply 5 pi over 6 by my conversion factor. Well, it's either going to be multiplied by 180 over pi or pi over 180. Well, if you're using your conversion from science, we're going to want to get pi to eliminate. So we want to cancel those off. Well, 180 degrees is the same as pi, so if we put this into the calculator or simplify this, I like to do with smaller numbers. If I divide 180 by 6, I get 30 times 5 is 150. So this is 150 degrees. Now, 150 degrees, if you remember, is on the unit circle, so that's kind of easy to do that. But what if it's not, or actually, let's do another exact value while we're here. So 7 pi over 18, we want to get rid of the pi, so that goes here. Again, what I always like to do is make the number smaller. Instead of multiplying 7 by 180, I do 180 over 18, which is 10, times 7, which is 70. So those reduce easily. What happens if you have a problem that tells us to round to 3 decimal places? Well, we're still going to do the same math. We're still multiplying by 180 over pi so that the pi's cancel off. And if you put in the calculator negative 180 divided by 14 and round to 3 decimal places, you get negative 12.857 degrees. Now notice that I put degree symbols on all of these, so make sure that you're putting degrees in degrees. Radians are just numbers. Well, 3 doesn't have a pi in it. How do I convert that? Well, the same way you did all the rest of them. We're multiplying by 180 over pi, put this into the calculator, and you end up getting 171.887 degrees. Which if I ask you to sketch 3 and sketch 171.887, you're going to get the exact same angle. Well, what if I'm converting from degrees to radians? Well, same thing that we're doing with the conversion, but instead of getting rid of pi, we're trying to get rid of the degree symbols. Well, what goes with the degree symbol? Well, 180. What's also equivalent to 180? Pi. So if you were to put this, or try to simplify this, you have 100 over 180, which are both divisible by 10. So you end up getting 10 pi over 18, which can be reduced to 5 pi over 9. And then the same thing for all of these. We take our degrees and multiply by a conversion factor of pi over 180 because we want to get rid of the degrees and they have to be on opposite sides. So then we have, they're both divisible by 100, or 10, sorry. So 2 pi over 18, or 28 pi over, so we got the 8. 28 pi's over 18, which reduces to 14 pi over 9. And then same thing for negative 80. We're going to multiply by pi over 180, divide both by 10, get negative 8 over 18, which reduces down to negative 4 pi over 9. So what we're going to eventually do is put these radians on the unit circle. So these are going to be very important ones to memorize. So how do I convert 30 degrees to radians? Well, we get rid of the degree symbol by multiplying by 180, or pi over 180. You get 30 over 180, which is pi over 6. If you do the same thing with 45, you have 45 over 180, which ends up reducing to pi over 4. And then lastly, 60 degrees, if we multiply that by pi over 180, you end up getting a third. Well, we kind of talked about these already. Drawing these on, like in radians, 0 degrees is the same thing as 0 radians. 90 degrees is the same thing as pi over 2, because pi is the same thing as 180. 270 degrees is the same thing as 1.5 pi's, or 3 pi over 2. And if I'm just going to do negative 270, I'm just going to do negative 3 pi over 2. Just like if I'm doing negative 180, it's going to just be negative pi. So how do I figure out the reference angles for each of the following? Well, what's kind of helpful to do is to maybe draw these out. 7 pi over 3 is the same thing as 2 and 1/3 pi's. That means if I were to draw this out, I would go 2 pi's, which is a full circle, and then the third, and that's that. The reference angle is always the angle that's created between the horizontal axis and that terminal side. So how much did we go past 2 pi? Pi over 3. Since we're right here on 17, I'm just going to draw 5 pi over 6. So 5 pi over 6 looks something like this. How much does it take to go back to the horizontal axis? Well, how much does it go to get to pi? What is pi minus 5 pi over 6? Well, pi over 6. which is very similar to what we did with reference angles and degrees, where we're trying to get back to 180, but 180 degrees in radians is pi. What about negative 4 pi over 3? Well, that's the same thing as negative pi and a third. So something that maybe looks something like this, which again, we're trying to figure out what's the angle that's created between the horizontal axis and that terminal side. Well, how much did we pass up pi with? A third. And then lastly here, 3 pi over 4 looks something like this. So how much angle do I need to get back to the horizontal axis? Pi over 4. So same thing that we did in degrees. You're just trying to get back to the horizontal axis. So just kind of draw it out and figure out how much does it take to get back to the horizontal. So make sure you practice this stuff in your assignments. Ask questions if you have them.